The future is coming, and sooner than you think. These emerging technologies will change the way we live, how we look after our bodies, and help us avert a climate disaster. Technology moves at a rapid pace these days. It can sometimes feel like every single day there is a new technology that is going to revolutionize the future. But with so many massive technological upgrades happening all the time, it is easy to lose track of the amazing ways the world is progressing. We've gathered the most exciting future technologies. Necrobotics, which, as the name suggests, involves turning dead things into robots. A team of researchers turned a dead spider into a robot-like gripper, given the ability to pick up other objects. To achieve this, they take a spider and inject it with air. This works because spiders use hydraulics to force their version of blood, hemolymph, into their limbs, making them extend. Right now this concept is in its developing stages, but it could mean a future where dead animals are used to further science. Finnish engineers who have found a way to turn sand into a giant battery. These engineers piled 100 tons of sand into a 4 by 7 meter steel container. All of this sand was then heated up using wind and solar energy. This heat can then be distributed by a local energy company to provide warmth to buildings in nearby areas. Energy can be stored this way for long periods of time. All of this occurs through a concept known as resistive heating. This is where a material is heated by the friction of electrical currents. Exoskeletons have existed for years, both in popular science fiction and real life. But as the years have gone on, the technology has rapidly become more impressive. Most notably in recent years, we have seen the technology now become more readily available for the young. The Atlas 2030 is described as the most advanced mobile medical exoskeleton designed specifically for children. While it is not commercially available yet, this technology could aid children in the future, offering a pediatric lower body medical exoskeleton. Who would have thought the best way to get satellites into space was with a makeshift catapult? Spin launch is a prototype system for getting satellites or other payloads up into space. It does this by using kinetic energy instead of the usual technique of using chemical fuel found in traditional rockets. This technology could be capable of spinning payloads at 8,000 km per hour and 10,000 g, then launching them skyward through a large launch tube. The company has signed an agreement with NASA and is now testing the system. Xenotransplantation is the procedure of transplanting a human with cells, tissues or organs from an animal source, has the potential to transform surgery. One of the most common procedures performed so far is the insertion of a pig's heart into a human. This has now successfully happened twice. However, one of the patients was only alive for a few months, and the second is still being observed. In these surgeries, the heart cannot be instantly put into a human, gene editing needs to take place first. Right now, these surgeries are risky and there is no certainty around success. However, in the near future, we could see xenotransplants happening on a regular basis, providing hearts or tissues from animals to humans in need of it. The use of brain-reading technology has improved hugely in recent years. One of the most interesting and practical uses we've seen tested so far comes from researchers at the Swiss Federal Institute of Technology Lausanne. These researchers have managed to create a means for tetraplegic patients, those who can't move their upper or lower body, to interact with the world. In tests, the robot arm would perform simple tasks like moving around an obstacle. In the future this could lead to wheelchairs controlled by the brain or assistance machines for tetraplegic patients. One of the most interesting uses of the technology is the building of 3D printed bones. The company Ossiform specializes in medical 3D printing, creating patient-specific replacements of different bones from tricalcium phosphate, a material with similar properties to human bones. Using these 3D printed bones is surprisingly easy. A hospital can perform an MRI which is then sent to Ossiform, who create a 3D model of the patient-specific implant that is needed. The surgeon accepts the design, and then once it is printed, it can be used in surgery. Scientists have found a way to store energy in the red bricks that are used to build houses. Researchers led by Washington University in St. Louis, in Missouri, U.S., have developed a method that can turn the cheap and widely available building material into smart bricks that can store energy like a battery. The researchers developed a method to convert red bricks into a type of energy storage device called a supercapacitor. This involved putting a conducting coating, known as petit, onto brick samples, which then seeped through the fired brick's porous structure, converting them into energy-storing electrodes. Scientists have developed what they call living concrete by using sand, gel, and bacteria. Researchers said this building material has structural load-bearing function, is capable of self-healing, and is more environmentally friendly than concrete, which is the second most consumed material on Earth after water. The team from the University of Colorado Boulder believe their work paves the way for future building structures that could heal their own cracks, suck up dangerous toxins from the air, or even glow on command. Scientists have found a way to attach artificial neurons onto silicon chips, mimicking the neurons in our nervous system and copying their electrical properties. Until now, neurons have been like black boxes, but we have managed to open the black box and peer inside, said Professor Alain Nogaret, but it's wider than that, because our neurons only need 140 nanowatts of power. Researchers hope their work could be used in medical implants to treat conditions such as heart failure and Alzheimer's, as it requires so little power.